Last time we started section 10.4, we actually got a very good way into it, and we were at the point where we were talking about normal distributions. And we had talked about, before we did that, standard deviation, which we're going to see occur again in that. And so standard deviation, if you remember, had this process by which we used our data to calculate how far something is spread apart. And basically that relates to this empirical rule, and this only works for normal distributions. So if I were to ask you to create something that has a normal distribution question kind of thing, I sometimes ask you to do that on tests, right? And you don't say in the problem that it's normally distributed, you've got a problem, because this is not true for every set of distribution. It's true only if it's normally distributed, and not everything is. So keep that in mind. We're going to be working with data that is normally distributed to actually have this happen. Oh, let me make mention of these percentages first before we move on. Okay, so I drew this picture last time. There's this normal curve, and the mean is the peak in the middle. That's the mean. And then we've got this information that says that we have 68% of the data within one standard deviation, 95% within 2, and 99.8 within 3. So what does that look like in terms of the curve, and how is that going to affect as we do our problem? Well, each time you have a problem like this, what you're going to do is you're going to draw me a curve. And it's going to look more symmetric than mine because you're going to draw better than I do, I'm sure. But what you're going to do is this distance right here is the one standard deviation away. I'm just going to put the number 1 down here for a moment, that I've moved 1 in each direction, and that's 1 standard deviation. What this is saying is that this shading inside of here is 68% of the data values. Okay, so whatever that standard deviation is, and we'll work with some so you can see it work, but whatever moving 1 standard deviation in each direction is, 68% of your data lies there. Now, we have the possibility of moving 2 standard deviations as well. So if we're 2 standard deviations out, not only do we have the same information we had before, that is, this part that's already in blue is between there, but now we have more, right? We have everything now that I've highlighted in yellow. So the blue, the yellow, all of that, I mean, it's all inside there now, but it's the yellow that we're talking about. That's 95%, and it includes the 68% part of it, right? Part of it's the 68. And then if we went out 3 standard deviations in each direction, and it should look symmetric, and of course I've run out of space on the right-hand side, so it's not looking symmetric, but just pretend for the moment. And we talked about the area within 3 standard deviations, which I'm now highlighting in red. That would be 99.8% of the data, which is practically speaking everything, right? And very, very, very few values outside of that particular area.
So
yes?
How do they get those percentages?
Those percentages are based on the calculations for finding the standard deviation. So those go hand in hand. Yeah. And it has to do with it being normally distributed. If it's not normally distributed, you can't say this about the data.
And is that like half and half usually? Like it's either normally?
It's not like that. It's just whatever the data is. Yeah. I mean, and a lot of the data, I mean, you'll see when we start doing a problem on the standard deviation that affects what it sort of looks like and how you think about it. So let me do an example. I think it might help you to sort of see how this works. And then if not, we can talk more about some questions, okay? Okay. It says assume a normal distribution. We need that, or we're not going to be able to do the problem. And that the average phone call in a certain town lasts 8 minutes, with a standard deviation of 2 minutes. And the first question is, what percentage of phone calls lasted between 6 and 8 minutes? So the first thing you're going to do on every single one of these problems is you're going to draw a normal distribution. And your distribution doesn't have to be perfect. Mine never will be. And you're going to mark the mean in the middle with the value they give you for it, which is what? 8. The next thing you're going to do is you're going to use the standard deviation to mark the next 3 spots to the left and the right. Now, not all the problems require 3 spots, so if it only goes out 2 spots because that's all the data you have, that's fine. But generally speaking, just as a get-go, we're going to mark them all out. It's easier. Okay? All right, so this says the standard deviation is what? 2, which means that as I move to the left, I'm going to subtract 2, and as I move to the right, I'm going to add 2. So on the left, I've got 6, 4, 2, and on the right, I have 10, 12, 14. So far, so good? Okay, so the 1 doesn't mean 1 unit. It means 1 standard deviation, whatever that value is. And the standard deviation in this problem is 2. The next thing we're going to do is we're going to actually shade or mark in some way which part of this diagram corresponds to the question that's asked. So the question they ask is about 6 to 8 minutes. So So in terms of my diagram, that's this piece right here. Right? Okay. Now, that's not exactly the information that's given to me on these percentages, but it's always able to be found from that information. We just have to think through how we would use the information. So what are you thinking when you see this on how to use that?
68 divided by 2.
Right. So this is only one standard deviation in one direction, and normally it's 2 directions, so it's half of it. So this is going to be 68% divided by 2, which gives me 34%. And that's exactly how these problems are always going to work. All right, so far so good? Okay, let's try another one. Same question or same data at the beginning, but now the question asks, what percentage of the phone calls lasted less than 4 minutes? Okay, so now if you've already got the diagram and you want to keep using your same diagram and shade in a different color, more power to you. I should have used mine before I shaded anything, and then I could copy and paste it. So we have 8 here, 2, 4, 6, and 10, 12, 14. And now I'm going to shade less than 4. So we're over here now, right? Is everybody good with the shading? Now that looks even less like the values that I was starting with before, right? The 68 and the 95 and stuff like that. But can you think of how you might figure out what you would do for it? There's at least a couple of ways to think about it.
Well, I was thinking,
Okay, Andrew, you got the floor. What are you thinking?
I was thinking, and I don't know if this is exact now, but you said all of it within those 3 standard deviations is 99.8, which is almost everything.
Yeah.
So if we see it's 100%,
Mm-hmm.
and it's divided into 6, we just divide that 99.8 divided by 6.
Okay.
100 divided by 6.
So the answer to your question is actually no, and the reason is because this information, well, I'm sorry, I don't want that color. This amount of area would be different than this amount of area, right? So dividing by 6 won't work. But you're right on part of what you said. You said there's basically 100% of the area, and that is a true statement. We are going to use that, or at least one of the ways to do this is to use that information. Hannah.
Couldn't you just take the standard deviation, like with the two over?
Okay.
2 units over, and then like subtract.
Okay, so like from 4 to 12,
Yeah.
that would be 2 standard deviations. How much area is in that region, Hannah? Do you remember?
Isn't it 95?
Okay, so this is 95%.
Yeah.
Okay, so what does that tell me next?
But there's 5% left.
So that means if there's 100% total, there's 5% left that's sort of on the outside. Is everybody good so far? Now, that's not quite answering my question just yet. What would I have to do?
Divide by 2.
Right, I need to divide that by 2. So this would be 2.5% or 2.5% of the phone calls actually lasted less than 4 minutes. Make sense?
So you don't worry about the 99.8. You just pretend it's 100.
Well, it's not 99.8 because we're not just going back from 2 to 4, right? We're going all the way back to like a phone call that lasts a second.
Yeah.
So that's why that works. Yep, Lauren.
I'm not understanding how we got the 95%.
Okay. Can somebody help Lauren with that? Where do we get the 95%? The empirical rule. Yeah. The empirical rule right here says that if we're 2 standard deviations away, we're going to be 95% of the data.
Oh, okay.
That's where that came from. Okay, Amy.
So why wouldn't you just do it like before when you took like the 95 divided by 2?
You could. That's the other way to do the problem. So I'm glad you mentioned. I was about to say it next too. All right. So Amy's asking basically why we couldn't just focus on half the graph. Does that sound like a fair assessment, Amy? Okay. If we focused on half the graph, could we find this half right here that's between 4 and 8? Yeah, it'd be half of 95, right? That's what? 47.5. So then what would we do to find the area we really want, this outside area then?
50% minus.
You'd have 50 minus that, and that's the other way to do the problem. Very good. Okay. This graph is very symmetric. We got 50 on one side, 50 on the other side. You can split everything, when you want just one side of it by 2. All those things are really good. Do you have a question, Lauren?
What would you subtract 47.5 from?
From 50.
Because it's, oh,
Okay.
Yeah, because you're talking about half the graph from the mean to the left, all the way to the left. Okay, you ready to do one more? I'm not going to talk. I want you to do the problem on your own. Part C. Start with the same picture, and then we'll make sure that everybody has the same answer. Okay, is everyone done with that one? Okay, so look at the person next to you and say, didn't we just do that? Yeah? Okay, it's equivalent question though, we just did, right? Okay, it's the other half. All right, so we're actually asked to find this area over here, right? And we can do it one of the same two ways that we just talked about, either taking the 100%, taking away my 95 in the middle and divide by 2, or taking the 50% and taking away the 95 divided by 2, that half of it, and getting the 2.5%. So either way we do it, this is actually the same problem that we just did. Okay, everybody good with that? Okay, great. Let's take a look at a different one. This is IQ scores. This is, at least the fact that IQ scores are normally distributed is a true statement. Okay, IQ scores are normally distributed. That is a true statement. I'm not sure, I should look up, but I just got this question out of one of the versions of the book. I don't know if it's in this version of your book or not. So I don't know for sure that the mean and the standard deviation are accurate necessarily, for real, but they are normally distributed. Okay, so this one says that we have IQ scores that are normally distributed. The mean is 100 and the standard deviation is 15. And we're told in this problem that we have 1,500 students, and we'll talk about how we're going to use that at the very end of each part of the problem, okay? But we start this problem just like we did the phone call problem, by drawing the curve and putting in the information about mean and standard deviation for this particular problem. Okay, so the mean is 100. So if I go out one standard deviation, what are the two values that I would need?
85.
Good, 85, 115. How about the next two standard deviations? Ooh, 70, good. And 130. And then one more? Okay. So the first question talks about having an IQ between 85 and 115. So where is that on this diagram? One standard deviation in either direction, right? Okay. What percentage of the data is that? 68%. Now, that doesn't exactly answer the question.
It's 68% of 1,500.
Right, it's 68% of the 1,500 students, right? Because this actually asks me how many students. So I really want to give a number of students. That's what they're asking me for in the problem. So there's a couple of ways I could do that. We'll go with one of the ones that we've seen recently in class, which is using proportions. You guys remember using proportions? So we did that by saying we had 68 over 100 equals, very good, x over 1,500, very nice. And then we cross multiply. So what is the first, what does the next step give me? 102 what? 1,000, so 3 zeros next, yeah? Okay, and then divide by 100 on each side. So how many does this give me?
1,000.
And there are units to this, right? It's students. Many of you said it as you're giving me the answer. Right, we're going to write down that this is students. Now notice we did give units on the last problem. What were our units? They were percent. So we didn't actually say we were doing units, but we did it. Okay? So 1,020 students are in this sort of a 68% range in the middle here that I've shaded in yellow. Okay, ready to try the next one? Okay, I'm going to let you guys get this one. We can shade it together, and then I'm going to have you calculate it. Where am I going to be shading? The right side of 145, over here, right? Okay, see if you can figure out what percent that is, and then figure out how many students that corresponds to. We'll talk about that. You're going to have to round. Yeah, Alyssa's right. I'll tell you what you're not going to say, Andrew. You're not going to say 3.7 students, right? Not going to say that. Yeah.
Is it safer to round up or round down?
We'll talk about it and how you do the rounding. Okay, raise your hand if you've found a percentage at this point. No, Kayla? Okay. Like, don't know how?
Yeah.
Okay. Raise your hand if you're stuck on how to find the percentage. Okay. Some of you found the percentage, some of you haven't. So there's a couple of ways, again, to find the percentage. So someone who has found the percentage, can you walk me through how you found the percentage? Erica, you want to do it?
I did 100 minus 99.8
Okay, so why did you do 100 minus 99.8?
because I wanted to find just the two very end parts.
So this is actually going to find the space, well, I'll mark it in a different color. The space here and here
Yes.
in blue, right?
And
Okay, and then
that's
why was it 99.8?
because everything in the between that is the 99.8.
Okay, so that's my 3 standard deviations, right?
That's 3 standard deviations.
Good. Okay, so minus the 99.8, and then what did you do after you did the 100 minus
And then I
99.8?
divided it by 2 because I only
Fantastic.
wanted one of them.
Good. So this is one way to find a percentage. Did anybody find the percentage differently? Okay, what did you do to find your percentage, Emily?
I did 99.8 and then just divided it by 2 right away
Okay.
to get 49.9%. And then that was 0.1% difference between, because it's 50% on 1/2. So.
Okay, do you guys see what she did? Now, it's the same math. She did a division by 2. She did a subtraction. She just did it basically in a different order. She considered only the right half of the graph, so it was 50%. And then she used that one piece that was 3 standard deviations away, which was half of 99.8. All right, so either way we do it. What percentage do we get?
0.1. Yeah.
Point what?
1.
0.1, like this?
Yep.
Okay, and that's a percent, right?
Yes.
Keep that in mind. It's a percent. That's not just the number 0.1. Doesn't quite answer my question in full. I'm supposed to be finding the number of students. So how do I do that? A proportion is a good way to do it. So how would I set up my proportion?
You do 0.1% over 100
Okay.
equal to x over 1,500. And then with the percentages, I changed them into decimals, so that would be easier to work with. Is that okay?
I don't think we need to change it into the decimals because the 0.1 over the 100 already in effect does that.
Okay.
Yeah, so we should be able to just leave them as they are to do the cross multiplication. So I had 100x. What happens when I do 0.1 times 1,500? That's 150. And then when I divide by 100, weird things happen. What do I get? 1.5. And like we said, that reporting 1.5 students is probably not your best choice. So we're going to round. And what we're going to do, Andrew, is we're going to round with normal rounding rules. So 0.5 and up, we're going to round up. 0.4 and down, we're going to round down. So on this one, we're going to round this one up, and we're going to say then the answer would be 2 students.
Would you say about 2 students?
You could. Okay, let's take a look at the last part of this one. I think there's a part C, right?
Yes.
This one's a little trickier.